Performing descriptive statistics using SPSS. Dataset, use the data file. data3.sav. Frequency distribution commands. Analyze next. Descriptive statistics. Next. Frequencies. Next. Select the variables, sex and religion, and push them into the Variables box. Next. OK. Frequency distribution. Central tendency and dispersion commands. Analyze next, descriptive statistics. Next, frequency. Next, select the variable and push it into the Variables box. Next, statistics. Next, select all the descriptive measures you mean, median, mode, SD, SE, quartile, skewness, kurtosis. Next, select percentiles. Next, write 30 in the box. Next, add next write 40 in the box. Next, add next. Continue, next, OK. Central tendency and dispersion. Skewness and kurtosis. These two statistics are used to judge whether the data have come from a normally distributed population or not. In table, we can see the statistics for skewness, -0.092, and kurtosis, -0.288. Skewness indicates the spreadness of the distribution. Skewness indicates data is skewed to the right. Skewness 0 indicates data is skewed to the left, while skewness indicates data is symmetrical, normally distributed. The acceptable range for normality of a data set is skewness lying between -1 and +1. Quartile and percentile. When a dataset is divided into 4 equal parts after arranging into ascending order, each part is called a quartile. It is expressed as Q1, first quartile or 25th percentile, Q2, second quartile or median or 50th percentile, and Q3, third quartile or 75th percentile. On the other hand, when data is divided into 100 equal parts after ordered array, each part is called a percentile. We can see in Table 4.4 that percentile 25 means Q1, percentile 50, Q2, and percentile 75, Q3. For age are 21, 27, and 32 years, respectively. Q1, or the first quartile, is 21 years, means that 25% of the study subject's age is less than or equal to 21 years. On the other hand, 30th percentile, P30, is 22.3 years, which means that 30% of the study subject's age is less than or equal to 22.3 years. Central tendency and dispersion. Alternative method commands. Analyze next. Descriptive statistics. Next. Explore. Next. Select the variable age and push it into the dependent list box. Next. Plots. Next, select stem and leaf and histogram. Next. Continue. Next. OK. Output. Central tendency and dispersion. Alternative method. Box plot. Interpretation. We can see that the SPSS has provided mean and 5% trimmed mean of age. 5% trimmed mean is the mean after discarding 5% of the upper and 5% of the lower values of age. The extent of the effect of outliers can be checked by comparing the mean with the 5% trimmed mean. If they are close together, there is no significant influence of the outliers, or there are no outliers, on age in the dataset. If they are very different, it means that the outliers have significant influence on the mean value, and suggests for checking the outliers and extreme values in the dataset. The 95% confidence interval, CI, for the mean of age, which is 25.49 to 27.53. The 95% CI for the mean indicates that we are 95% confident, sure, that the mean age of the population lies between 25.49 and 27.53 years. Histogram gives us information about A. Distribution of the dataset, whether symmetrical or not, B. Concentration of values, and C. Range of values. Looking at the stem and leaf chart, we can have an idea about the distribution of the dataset, whether symmetrical or not. The box and plot chart provides information about the distribution of a dataset. It also provides summary statistics of a variable, like Q1, first quartile or 25th percentile, median, second quartile or Q2, and Q3, third quartile or 75th percentile, as well as information about outliers or extreme values. Descriptive statistics disaggregated by a categorical variable. Commands: analyze next. Descriptive statistics, next. Explore, next select age, and push it into the dependent list box. Next select sex, and push it into the factor list box. Next. Plots, next. Deselect. Stem and leaf, and select histogram, next. Continue, next. OK output. Checking for outliers. Command analyze next. Descriptive statistics. Next. Explore. Next select the variable age and push it into the dependent list box. Next select ID no, and push it into the label cases by box. Next select statistics under display section, next. Statistics, next. Select outliers, next. Continue, next. OK. The SPSS will provide 5 upper and 5 lower values of age with the corresponding ID, serial numbered numbers, as shown in table. Output: checking data for normality. This is an important assumption for doing a parametric test. Whether the data have come from a normally distributed population or not can be assessed in several different ways. The commonly used methods are A. Graphs, such as histogram and QQ chart. B. Descriptive statistics, using skewness and kurtosis. And C. Formal statistical tests, such as one-sample Kolmogorov-Smirnov, KS test, and Shapiro-Wilk test. Suppose we want to know whether the variable systolic B, PSS variable name, OSBPDP, is normally distributed in the population or not. We shall first construct the histogram and QQ chart. Histogram command. Graphs. Next, legacy. Dialogues. Next, histogram. Next, select the variable SBP and push it into the variable box. Next, select display normal curve, clicking at the box below. Next, OK. Output. QQ plot command. Analyze next. Descriptive statistics. Next QQ plots. Next select the variable SBP and push it into the variables box. Next, for test distribution select normal, usually remains as default. Next, OK output. KS test and Shapiro-Wilk test command. Analyze, next, descriptive statistics. Next, explore, next. Select the variable SBP and push it into the dependent list box. Next, plots. Next, deselect stem and leaf and select histogram. Next, select normality plots with test. Next, continue. Next, OK. Output. Interpretation. Histogram provides an impression about the distribution of the dataset, whether the distribution is symmetrical or not. If we look at the histogram of systolic BP, it seems that the data is slightly skewed to the right, i.e., distribution is not symmetrical. The QQ plot also provides information on whether data have come from a normally distributed population or not. The QQ plot compares the distribution of data with the standardized theoretical distribution from a specified family of distribution, in this case from normal distribution. If data are normally distributed, all the points, dots, lie on the straight line. Note that our interest is in the central portion of the line. Deviation from the central portion of the line means Non-normality. The specific tests, objective tests, to assess if the data have come from a normally distributed population are the KS, Kolmogorov-Smirnov test, and Shapiro-Wilk test. Look at the SIG, significance column of table. Here, SIG indicates the p-value is 0.000 for both the tests. A p-value of less than 0.05 indicates that the data have not come from normally distributed population. In our example, the p-value is 0.000 for both the tests, which is less than 0.05. This means that the data of systolic BP have not come from a normally distributed population. Here, the null hypothesis is data have come from a normally distributed population. The alternative hypothesis is data have not come from a normally distributed population. We will reject the null hypothesis since the p-values of the tests are less than 0.05. Thank you.